Welcome. My name's Robert Fanfant. My call sign is N7QT. And I wanted to thank Mel Ming for recording this presentation, as well as the Spokane DX Association for hosting this video. I did this video thinking back as to how to be helpful given some of the major issues that we as amateur radio operators faced this past year. And what could we have done differently? For example, in the case of 3Y0J, as well as VP6 Delta, which I was a part of, the Fox was transmitting on the wrong cycle. In the case of the Bouvet operation, their clock was off by 15 seconds. And in the case of the Ducey expedition, I had accidentally hit Control F6, which inadvertently caused the Fox to change cycles. We had a case on Sable Island where one station had timing issues. Their clock would advance 1.5 seconds for 3 or 4 minutes and then shift back to internet time and then just randomly jump all over the place every 3 to 4 minutes. We had a case of T30UN who was missing Roger 73s. In my case, I worked them 4 times, and I only once received a Roger 73, and I only logged them once. What I'd like to do in this presentation is to state what our goals are, followed by reviewing standard FT8, followed by Fox Hound mode FT8, and then I'm going to talk about the application differences that Foxes use to work U-Hounds. Once we understand those differences, we understand standard mode as well as Fox Hound mode, we're going to put it all together by learning to adapt. And I'm going to conclude the presentation with some upcoming improvements to FT8. The goal of this presentation is that all of you, after hearing this presentation and understanding what is being communicated, you will have all of the required tools to work any DX station using FT8. So let's talk about standard mode FT8. I wanted to cover standard mode FT8. In this case, we've got a DX station called the VP8 PJ calling CQ on an even cycle. We've got N7QT responding to the VP8 PJ with his grid square. VP8 PJ picks up N7QT and sends N7QT a -10 signal report. N7QT responds with a Roger acknowledgement that it received VP8 PJ signal report and sends a Roger 01 back to VP8 PJ. At which point VP8 PJ sends a Roger, N7QT responds with a Roger 73, at which point the DX station concludes with a Roger 73. Total lapse time is 2 minutes. Same sequence occurs in standard mode FT8 with the exception of VP8 PJ concatenates the Roger and the Roger 73 into one event so that we now have reduced 15 seconds off of the entire transaction. We have a very smart guy, Mel, N7GCO, who sends a signal report at the same time that N7QT is sending his Roger 73. In this case, the DX station, VP8 PJ, can respond to N7GCO with a Roger signal report, at which point N7GCO can conclude the transaction with a Roger 73, and VP8 PJ concludes with a Roger with a 73. At this point, the entire transaction has taken a minute. Now, why is this important? For example, on 60 meters where Fox Hound mode is discouraged and the Fox normally doesn't care about grid square. If we follow this stream of events, we can cut the average time for transaction on 60 meters to a minute from start to finish. So I would highly recommend that most of you who are working the Fox in standard mode not send your grid square and send a signal report instead. So one way of helping you achieve this is that in WSJ-TX, you can double click on TX1, which toggles between sending your grid square or moving directly to the signal report, which is TX2. You can also double click on TX4, which toggles between setting the Roger, 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 or the Roger, Roger 73. Obviously, the Roger, Roger 73 is preferred. So let's talk a little bit further about standard mode behavior. The two participants, say the fox and the hound in this case, I hate using that word because we're really just in standard mode, but the two individuals that want to complete a QSO in standard mode can use any frequency between 0 hertz and 4,000 hertz. Either the participants can use an odd or even cycle. Both parties conclude the QSO with either a Roger Roger 7.3 or a 7.3. And both parties are entitled or can run either split or simplex. And let's talk about what simplex and split means. Split means that the participants in the QSO are running different frequencies if they are split. If they are running simplex, that means they are both using the same frequency. Split is highly recommended. And you enable split by checking the hold TX checkbox so that your frequency stays locked. And again, this requires an accurate PC clock. And as you can see down in the waterfall below, all of the participants are spread out between 0 and, in this case, 3,000 hertz. Fox mode was created as a way to increase throughput rates specifically for expeditions. The WSJTX team, development team, created this new protocol based on the standard FT8 mode. In this case, it allows the Fox to chat with up to 10 stations during its even odd cycle. The reason I'm focusing on WSJTX is that it is the gold standard. It's open source, hence other applications like MSHV add functionality around WSJT's core. So how you enter Fox Hound mode is that you go into File Settings of WSJT, click on the Advanced tab, hit Special Operating Activity, and select Hound. Most of you will be Hound. The Fox, on the other hand, will select Fox and click OK. In the newer versions of WSJTX, there are several sets of buttons down here, one of which is the H, where you can toggle back and forth to go into or out of Hound mode. So let's talk a little bit about Fox Hound mode here. What's important to note is the Fox owns frequencies from 1,000 down. Hounds, on the other hand, own frequencies from 1,000 hertz and up. And I'd like to say well above 1,000 hertz, because what we often find is if a hound parks himself at 1,000, very often he shows up on the Fox's, inside the Fox's frequency range at 990 hertz. So therefore, I would highly recommend all hounds stay above 1,100 hertz. In this case, the Fox is running one stream, as indicated here, and the hounds are above 1,000. When the Fox calls upon a hound and picks a hound out of this set of hounds, the Fox moves the hound down into its working frequency, and the QSO will complete down in the Fox's working space. So let's walk through an example of a real live example of a Fox operation. In this case, we've got Sable Island, CY0S, calling CQ. In this case, he's running two streams at 360 and 560. You have a hound, KD7H, responding to CY0S with his grid squares. So KD7H is calling the Sable Island station with his grid square. Note the frequency. KD7H is operating at about 1,578 hertz. In this case, CY0S calls on KD7H and gives KD7H a +02 signal report. Note the frequency that CY0S is operating at, 619 hertz at this point. KD7H replies to CY0S with a Roger 12, meaning KD7H is acknowledging that CY0S's signal report and responds with a Roger -12. Note KD7H's working frequency. KD7H has been pulled down into the stream that CY0S was using, which is 619 hertz. Note what happens next. CY0S is responding to KD7H with a Roger 7.3. Note the working frequency. It has now shifted to 560 hertz. One of the very, very important distinctions as to how to determine if a fox is running in fox-hound mode is this one statement here. It is called a compound statement. Note that CY0S is talking to two separate hounds. In this case, it is CY0S is concluding the QSO with KD7H by sending him a Roger 7.3, but yet starting up a new conversation, a new QSO with W8 BLA by sending him a signal report or her a signal report. This defines a fox-hound. This defines fox-hound mode, where you'll see a fox working two stations in one stream. The other mode that I wanted to point out is that what happens if a fox is in fox-hound mode, but is called by a hound in standard mode. So let's walk through this. In this case, the fox is WA7CPA calling CQ, and the frequency is 627 hertz. That's the operating frequency of the fox. WB7TDU is responding to WA7CPA with their grid square. And note the working frequency, 1509 hertz. So again, the hound is well above 1,000 hertz, calling on the fox with their grid square. The fox responds to WB7TDU with a +37. Note the fox's working frequency, 627 hertz. The hound, on the other hand, stays at 1509 hertz and responds to the fox with a Roger acknowledgement and returns a +28. Note, in this case, the hound was not pulled down. Look what happens. The fox concludes the conversation, the QSO, with a Roger 7.3. So what does this all mean? It means that fox-hound mode will still work even if the hound remains in standard mode. So let's talk a little bit about fox mode behavior. The fox owns the frequencies from 0 hertz to 1,000. The hounds call the fox well above 1,000 hertz with their grid square, which is TX1. The fox transmits only on even cycles, or should only transmit on even cycles. The hounds should only transmit on odd cycles. And the QSO completes whenever the fox sends the hound a Roger 7.3. Another important behavior of fox-hound mode is that the fox attempts to work the hounds up to 5 times, at which point the fox moves on. You hounds, if you have not received a Roger 7.3 after 5 tries, you should start over again. Nowhere do you see in this fox-hound behavior that the hound is required to move down. That said, there's a huge advantage to the hound moving down because they are essentially guaranteed an exclusive frequency by the fox to complete their QSO. So instead of staying above 1,000, let's say in the case of WB7TDU, they were at 1,509 hertz. They could potentially be stomped on by another hound when trying to complete the QSO. So the long and short of it is that there's a huge advantage for the hounds to be in fox-hound mode, as they're guaranteed an exclusive frequency by the fox to complete the QSO. So let's talk about the two titans of fox applications. I would say 100% of all of the foxes are using either of these two applications. their behaviors are different. And it's very important for all of us to understand what those differences are. But in the case of WSJTX, it requires the hounds to call above 1,000 hertz. And again, I'll say well above 1,000. MSHV does not have that requirement. WSJTX expects hounds to call with a grid square, which is TX1. MSHV, on the other hand, treats fox hound mode and standard mode the same, meaning that if the fox was running MSHV, a hound could call either with TX1 or TX2, and MSHV would properly complete the QSO. That would not be the case in WSJTX's with WSJTX. Therefore, we should all aim for the lowest common denominator and assume that the fox is using WSJT. So let's talk a little bit about compound statements. I had mentioned it earlier. Another difference of MSHV and WSJT is that MSHV has a feature called multi-stream, which uses multiple streams but does not make use of a compound statement. It uses standard FT8 mode. Therefore, you should consider a multi-stream fox as just standard mode FT8. It is not fox hound mode. If you see this compound statement then the fox is in fox hound mode. If you do not see this compound statement in any of the fox transactions, then the fox is in using standard mode or multi-stream mode. Let's talk a little bit about band edges. In this case, this is a trace that was provided to me, and this is the fox's waterfall. As you can see on the lower frequency, there's a lot of frequency distortion at the very, very low end of the fox's frequency spectrum. Most transceivers have issues very close to the low end of the spectrum, say 0 to 400 hertz, as well as the very, very high end of the band pass. Therefore, if you find a fox that is showing up in this at 200 hertz on your transceiver, it would be best to move your VFO down so that the fox gets moved up into the 500 or 600 hertz range. Just be aware that you have to then add, if let's say you've moved your VFO down 200 hertz, make sure to add 200 hertz to this 1,000 hertz to stay well above that 1,000 hertz, to make sure that you, the hound, stay in the hound frequencies. And one of the things that you can do during transmit that WSJT allows you to do that I'd highly recommend is to enable either fake it or rig. And what this does is when your transceiver goes into transmit, WSJT will move the VFO so that your transmit frequency is always in a sweet spot. It does nothing for you on receive, but on transmit, it makes your transceiver very happy and keeps your signal relatively clean. So I would highly recommend all of you have either rig or fake it checked in the radio settings in WSJTX. So this is where we're going to learn how to adapt. What happens if the DX station has timing issues? We've already talked about how to determine whether the fox is running fox hound mode or standard mode. What happens if the DX is on the wrong fox hound cycle? How do we adapt? Before we get there, it's going to be very important for all of you to understand this delta time values. It's extremely important for all of you hounds to have a delta time of, say, less than 0.4 seconds, thereby improving your chances of getting decoded by the fox first. As you can note down here, you've got an individual that's 1 second off, but everybody else is relatively close. Again, there is no reason for you not to have a very accurate delta time, meaning the closer to zero you are, the more accurate your clock is. And there are several applications that we can use to sync our PCs, our computers, to an NTP server. The three applications that are commonly used are Meinberg, I'm going to introduce you to Txing if you've never used it before, as well as Dimension 4. It's extremely important to sync your computer clock. Most computers nowadays might drift a second, maybe 2 seconds at most per day. So if you were to sync your clocks every 3 to 4 hours, it's more than good enough. This is a USB dongle that you can purchase on any of the commercial sites. Nothing important about this GPS dongle other than the fact that it receives our American GPS satellites as well as the Russian GLONASS satellites concurrently. And I've used this in my home. I've got a 2-story house, and I was able to receive up to 12 satellites here in the kitchen going through a 2-story home. This next program called NMEAT Time by visualgps.com takes the output of the GPS dongles and syncs up your computer's clock. In this case, you can take a look at what it did for my station or my laptop. It got it to within 0.26 milliseconds of accuracy. This program runs about $25. And if you're going out in the field, it's relatively inexpensive to combine this with the satellite dongle and ensure that you've got an accurate time. So one of the programs that we can use to adapt our PC clock is Time Fudge. And how Time Fudge works is you basically enter the time that you'd like to offset your PC clock with. In this case, I've entered 1. Press Fudge, and it will essentially adjust your time. So notice here, prior to pressing Fudge, my clock was very accurate. 0.1, 0.1, minus 0.3. It's very, very close to the other amateur radio operators' clocks. As soon as I press Fudge, the time gets shifted by a second. So in this case, now my delta time is 1.0, 1.2, 1.1. So this application allows me to fudge my time. It has some features where you can hit Control Fudge to reverse the time. So in case you've gone the wrong direction, you can hit Control Fudge to reverse the time, or Alt Fudge resets it back to the original. One of the important things that you need to be aware of is you should stop the syncing of your PC time to the NTP server. What this means is if you're running Mindberg or Dimension 4 or Txing for that matter, you should stop syncing to the internet so that you can allow Time Fudge to control your clock, moving it back and forth. If you let your NTP server continue to run, what's going to happen is you're going to adjust this to -1 to try and stay in sync with, say, the Fox, and all of a sudden this NTP service runs, your Mindberg application runs and resets it, and you're no longer offsetting your PC clock. The other program that I would highly recommend folks get is called Txing. The latest version is v1.3. The beauty of this application is that A, it's free. It allows you to sync up to NTP servers, meaning this one application can keep your PC synchronized to a slew of time servers. But the other thing that is very neat about this application is, look at this. In this case, the station that I'd like to work, the UT0PR, his delta time is off by 1.2 seconds. With this application, I can right-click on this one entry and say, sync with this station. And it makes syncing to individual stations, individual decoded stations, very, very easy. It also has the ability with the calculate to calculate an average delta time and adjust your clock based off of the average DTs that you are receiving. You can also then just manually enter a time here as well and say update, and your PC clock will adjust. So this is a really, really simple application. I highly recommend folks. I've moved from Mindberg to this application. because of the ability to be able to sync to individual stations. So learn to adapt to not receiving a Roger, Roger 7.3. So in this case, we've got a station, K0UA, who has been calling the Fox. In this case, it's the Vatican radio station, HV0A. HV0A has sent, the Fox has sent this Hound, a Roger, Roger 7.3 up here. K0UA has never received the Roger, Roger 7.3 and continues to call with a Roger signal report and continues to call and continues to call and continues to call. In this case, it's very likely that K0UA has never logged the Vatican station because they did not receive their Roger, Roger 7.3 up here. So what's going to happen is the following day, K0UA discovers that the Vatican radio station has logged him. He is in the log, but he now no longer remembers when and where that QSO happened. How do we adapt to that? There is a file called all.txt in the WSJT directory. All you need to do is go into File, Open Log Directory, and select the all.txt file. And what this file contains is it contains every decode that has happened over a very, very long time. And so what K0UA could do at this case is K0UA could search for the Vatican call sign here and basically look back in the all.txt file for what date and time as well as frequency that the QSO happened. So this is a very, very valuable way of discovering QSOs that you have not logged, but they have logged you. Now, the one caveat here that's really, really important is that I'd say probably once a month, once every couple months, I would save the all.txt file into a different file name. For example, maybe March 2023 all.txt. Because this file will grow and grow and grow in size and pretty much consume a large percentage of your hard drive space. So if you're running an older computer with limited hard drive space, you definitely want to trim this file. If you feel that files that are older than 6 or 7 months that you'll never need them again, you should be able to delete them. Also, if you let this thing grow too large, it's going to be hard to open it, say, in WordPad or Notepad. So make sure you go into this file and save it off on a regular basis. So what happens in the case of Bouvet or VP6 Delta, where the Fox was transmitting on the odd cycle? How could we have solved that problem? You could either use JT Sync or time fudge. What we could have done in this case is that if the Fox is not transmitting on the even cycle like they should be, but they end up on the odd cycle, you could use either one of these two programs and subtract or add 15 seconds to get the Fox into the right cycle, at which point you could stay in Fox Hound mode and everything will work. What is the other tip that we've learned in this presentation? Switch to standard mode FT8. You now know that you can work standard mode FT8 with a station that is in Fox Hound mode and properly conclude the transaction. So in the case of Ducey Island or Bouvet, I could have switched, or you could have switched to standard mode FT8 and been able to complete the QSO normally. Now, remember we talked about how there's a huge advantage for the Hound to move down when called upon by the Fox. This is just a pro tip for some of you. You can achieve that by unchecking hold TX, so that if you get called by the Fox, who is in Fox Hound mode, and you are in standard mode, if hold TX is unchecked, as soon as the Fox calls you, you can double click on where the Fox is calling you and essentially move your transmit frequency on top of the stream that is calling you. So that is a pro tip where you mimic fox-hound behavior while you still stay in standard mode FT8. Now, the one caveat with this is you need to make sure in your file settings in WSJT that you allow there's a checkbox to allow you to change the transmit frequency at any time in the general settings. That needs to be checked so that you can at any time move your transmit frequency during the transmit cycle. But it works super well. So what you've learned so far is you've learned how to adapt to stations that are calling whose frequencies, whose delta times are moving around. You've got the tools to be able to run JT Sync or time fudge to basically keep up with the foxes who have whose clocks are unstable. You've also learned how to work stations who are running Fox Hound, but transmitting on the wrong cycle. The one things that the reason I wanted to include this here was that I've recently returned from a Palau DXpedition. We used the call sign Tango 88 Whiskey Alpha, and we ran last year. We were very, very fortunate as a member of our team to have Brian Moran, N9AGG, be a member of the team. Brian was a remote operator. Brian is probably one of the smartest guys that I've ever met. And he also is a developer on the WSJTX development team. We spent long hours chatting on the phone while we were on the expedition. Him and I were on the expedition. And we talked incessantly about what changes would improve that could be done to WSJTX to improve its usefulness. And I want to cover some of the upcoming changes. Some of them have already been incorporated, and there's some upcoming changes that have not yet been released yet. But one of the important things that came out of this expedition was that Al, K7AR, and Bob, W7YAQ, immediately after the end of our Palau expedition, went off to American Samoa. They were willing to use some of the updated WSJT code as the alpha test phase for Brian's update. So one of the things that got fixed was WSJTX was randomly changing the number of streams. So for example, very often I would say to WSJTX, I would like 3 streams. And what happened was WSJTX would sometimes use 1, sometimes use 2, sometimes use 3, even though there was a queue of people waiting to be worked. Brian found the bug that had been there from the very, very beginning of the WSJTX code. And now with this bug fix, the improvement of throughput has been increased by about 30%. Brian added some Fox enhancement so that typically what happens in the Fox operation is when I add someone into the queue to be processed, they get added to the very end of the queue. And some of the improvements that were added were now that I can manage it. For example, if I'm working a ton of Asia stations, for example, and I see 1 or 2 Americans come through, very often I'd love to add the Americans at the top of the queue, because if we are in Asia, we can work Asia at any time. But if a European or an American comes through, it would be nice to move them to the top of the queue, or a South American for that matter. It just depends on who has priority. So there's been a large increase in the ability to manage the queue. The other things that got added is we now have visibility into what the WSJTX engine is doing. So we know when an operator is going to be, basically when the QSO is completed or when there's additional work to be done. And most importantly is that one of the things that we suffered when we were in Palau on Tango 88 Whiskey Alpha, we had several pirates that were running. And so one of the features that Brian has added is to improve security so that the hounds will in the future be able to verify the real fox. And let me show you how that's going to work. So in this case, let's just pretend that this screen here is the fox working hounds. What's going to happen is that every so often, the fox N980G is going to send a series of 6 digits, and the 6 digits correspond to a date time. How this is implemented is that the fox has a secret password that all of the WSJTX stations know and are using. The password combined with the date time generates a unique 6-digit code. So you hounds will basically be seeing the fox spewing out 6-digit codes at certain date times. And what you can do is you can go to a website, the Fox's website, and verify that the 6-digit code that you received at this date time is the same as to what the fox sent out. So while this isn't 100% in terms of verification, it makes it extremely difficult for the average user to try to come up with these values. And these values will be shown on the website a few minutes after the fox has generated them. And that's it for the presentation.